Hello and welcome to the sixth video in this series making this simple Floppy Robin game for Android. I earlier on today did sort of part 1.1 of this series video showing how you set Cocos2dx up on Windows, which is pretty much identical to how I'm doing it on the Mac or you would do on Linux. And just to reiterate, from now on, if you're using Windows and Visual Studio for your C++ programming, or indeed already Eclipse, it's no different to what we're doing here, although I'm inside Xcode. The code is exactly the same. So if I just run the application to give us a reminder where we were, there's a little difference. You'll notice that the background in the application has no clouds in it. The robin still jumps, etc. And that's because we need to now, or just fire the app back up, start making the game look as if the robin is actually flying. And rather than move the robin, what we actually do is move the items in the background. So we'll want the landscape here to scroll from right to left, and we'll also want some cloud scrolling from right to left. And that's what we're going to do in this tutorial video. So when we're thinking about doing that, however, we'll obviously add our clouds as CC sprites, but to give it a little bit of depth, we're going to add two types of cloud. So we'll have a cloud that is moving quicker and is a little bit bigger, and a cloud that's smaller and moving a bit slower, so that it appears as the robin is so flying that there's some depth to the image that's presented on screen. It's not just simply 2D. Now I've already added a cloud which I took from Traffic Light Mania. I don't know whether you can see that well or not on the video, but there is a cloud there, believe me. Cloud-hd.png, you'll find that in the download with the code for this video. And now what I want to do is go about adding some clouds. Before we do that though, we have to have a little wander into our constants area here and have a think about some things. And I'm going to add in already a couple of constants, and I'm going to say kzindex cloud slow, and I'm going to leave this as 10, so the z-index for a slow cloud, and a kzindex cloud fast, so the fast cloud, I'm going to give it a z-index of 20, and therefore I'm going to give the robin actually a z-index of 100 now, because we'll be adding some other things in the middle. So this makes sure the robin is in front of the cloud, and the faster travelling clouds overlap the slower travelling clouds if they're on top of each other. Okay, so that's the first little bit dealt with there. The other thing I want to add in the constants now is when we add in the clouds, we'll be using the same image but simply scaling the cloud. Now I've had a little bit of a fiddle around with this already just to see, and we'll do k cloud scale, and then for the slow cloud, and for the slow we'll do a 0.4, and then we'll define a k cloud scale for the fast cloud, and we'll make the fast cloud a 0.85. So that gives us some sort of difference between how the clouds are moving. I'm just having a very quick look into some of the code I've already prepared as a reference to make sure I've got those scales right. Yes, I have. Good. Okay. The next thing I want to do is the way the clouds move across the screen. If I just run the application again, what we're going to want is we'll have some starting positions for the clouds, and what the cloud will need to do is when it goes off the screen to a certain point, so it's no longer visible, it wants its X position to actually go off the screen to the right hand side. So it scrolls to the left, goes off to the left, and we want to reposition it at the right and let it carry on scrolling. So what we're going to need is a constant to tell us what those positions are for being off the screen. So I'll define these as k, and let's call it cloud restart x. So that's the x position where it restarts, and we'll say that's 100 pixels, and that'll actually in the end be 100 pixels plus the screen width. And we'll do k cloud destination x, and in this case we'll make this minus 100, so the cloud is definitely off the screen before it gets reset. And that should be all of the things we need to do with our constants, and we can now think about how we're going to deal with our cloud. So what we'll do is right click on classes, and we'll do exactly the same procedure that was done for the robin here. We're going to subclass CC sprite, so I'm just going to go new file again, C++ class, make sure the target's selected and call this CCloud in this way, .cpp, and create. And I'm just going to be a little bit lazy here, and in robin.h I'm just going to copy this section here and drop this into cloud.h. We don't need the IO stream. And now just change some of the things inside here. So we've got a CCloud subclassing a CC sprite. We're going to create a cloud with a file name, and it'll be a CC cloud. I'm going to take the update and everything out here because we don't need them, and I'm also going to remove these variables inside here for now. So we've got our create statement, basically, well, our create function, static function defined as we did for the Robin, and now we can define the other things we will need. So looking at the private variables of what we'll need. So we'll need a speed that our cloud travels at, because it's either the slow or the fast cloud. We'll also need to store the screen width. You'll see why, just to make calculations a little bit easier. And what we'll also work out when we've provided those two parameters is the pixels per second that our cloud actually travels at across the screen. Going to the functions that we'll need publicly, we'll need a start function. So the layer will tell the cloud to start its motion. We'll need a stop, so when the game has stopped, when the Robin has fallen off the bottom of the screen, then we want the clouds to stop moving. We also will make a function not called void, called void. However, I hit the C twice, never mind. And here we'll have set speed and width, so we set the screen width and the speed for this particular cloud. So we take a float of the speed and a float of the width. And last but not least, we'll have a function in the private section called reached destination. And inside this function, what will happen is this will be called when the cloud has reached its off-screen destination to the left and needs to be reset to the right and set moving again. You'll see how that works when we start writing and filling out these functions now. So I'll take these function definitions here as usual and just go into cloud.cpp and drop these in, and I'll also go back into cloud.h, take reach destination and drop it in as well. And now what I need to do is put this CCloud with its colon in front of everything, like so. And that one goes like so, and I don't need the static, do I, on here? Okay, and now I can go about adding in the brackets as well for actually creating the function. A little bit dull, I realise, but people have commented they prefer in the videos when I actually do most of the code typing as well, because it's easier to follow along, so that's what I'm going to do. Okay, and now we have exactly the same code almost as we had for the Robin in the create cloud with a file name, so I'm actually just going to take this code and copy it and drop it inside here. And obviously there are probably better ways of doing this, of making sort of a game object class maybe that already has this in, so that we don't need to keep duplicating some code, but for this small example application tutorial it doesn't really matter. So we're creating our cloud sprite, initializing, we don't have the reset or the auto release on here, and that's finished as it is. Good, so that's really the easy part of the code with the cloud. And now we walk into the slightly trickier stuff that we have with the cloud. So the first thing we'll look at is this set speed and width. So inside here we'll, in fact, where is my IntelliSense? I'm just going to build this with Xcode and see if I've made any glaring errors somewhere, because whenever it stops popping up IntelliSense I always worry. Okay, build succeeded. Okay, good. Just going back into cloud.h. Okay, so we want to set our speed of our object then equal to the speed that's come in as an argument. We want to set our screen width, what did I call it? The IntelliSense seems to have completely broken here, unfortunately. Our screen width equal to the width. And now what we can do is, if I just take the name, we can take the pixels per second and we can set this value by saying that this obviously is then the screen width divided by the speed. And that reminds me of something else. Have we set up the speeds that we want to do for the clouds? No, we haven't set up the constants for the cloud speeds. So the speed is basically how many seconds the cloud should take to get across the screen. So I'm just going to define here and do cloud speed slow, and we'll set the slow to 28 seconds. And then I'm going to define k cloud speed fast, and we'll set the fast speed to 10 seconds. These are values I've tried out earlier and they sort of looked okay, and most of this will all be altered probably when there's actually something to do rather than just make the robin bounce, but for now we'll leave them as they are. Okay, so what we've done inside here then is set our pixels per second, and this is important for working out the time that the cloud's going to move from its current position when it started to being off the screen, so its speed is always consistent. So the trickiest part of the entire code in the cloud will be inside the start here to set the cloud actually moving. The first thing we're going to do is a little bit of a hack, but I'm going to call something called stop all actions. Stop all actions. And I'm getting a little bit annoyed with this because Xcode seems to have lost the indexing completely. So what I'm just quickly going to do here is just close the project file and reopen the project file and see if it rebuilds its index. Yes, it's indexing, loading the index, because that was getting a little bit irritating, because without the IntelliSense this is going to take a while. Okay, so we've stopped all the actions on our cloud, and what we need to do now is we need to run what's called an action on our sprite, and if you haven't seen those before then you're about to, but basically we can perform various things or tasks on our sprites. We can, like I've said before, we can fade them, we can move them, and we can also call functions with an action. So what we're going to do here is create an action that moves our cloud from its current point with its defined speed in pixels per second to its destination, and its destination will be the cloud destination x there. So it will move with its consistent speed there, and when it gets there we're going to call this reached destination function. And what this reached destination function is going to do is going to set then the position of the cloud to the restart x, so off the right hand side of the screen, and then call start again to start the movement across the screen to the destination off the left hand side. Might be a little bit confusing, so let's get on with the code, and I'll do this as verbose as possible. So we'll say that the current x equals this and get position x, so that's the current x that our cloud is sitting on. And now we want the distance that we're going to travel. So the distance that we're going to travel obviously is our current x minus our k cloud, and I can't remember what I've called it as usual, so k cloud restart, k cloud destination x. And I also, of course, at the top here need to include our constants header as well, so we have the constants. Good. Okay, so the distance that we're going to travel is this number of pixels, the current x minus the destination x, which remember is off the left hand side of the screen. And now what we can do is because we know our pixels per second, we can work out the time that we're going to be traveling. So we can say our time is equal to our distance divided by our pixels per second. The last thing we need to do is actually specify as a point where we're going to. So we'll make a point, a CC point. We'll call it destination, and we set this equal to CCP, and then we've got K cloud destination X, and the Y is obviously the same Y that we have now, so we say get position Y. And now we have everything we need. We have stopped any current actions on the cloud, just in case there are any. I'm wondering why this is here. I've forgotten to put in the using namespace Cocos2d. That should all be alright now. I need a semicolon. So we have the distance we're travelling, the time we're travelling, and the place we're travelling to. So we've got everything we need now to set our cloud actually moving. And the way we do this then is to use something called an action, and we're going to use a move action, and it's called CC move to, and we'll just call this action move, and all we have to do is call a static function on CCMove2, and we say create, and then we just want the time and the time and the destination, and that's all there is to it. So that's an action now which will move our sprite to this destination over the specified time. What we want to do, we've reached the destination, however, is call this reached destination, and we're not calling with any arguments or anything. So to do that, we use something called CCallFunc, and it's CCallFuncN, I think, which means no arguments or anything. I'm not sure, but it's the one we use, and we'll call this action move done. And we go here CCallFuncN, and here there's also a create where we specify in what object, which is in this object obviously we're calling this, and then here we have to specify the selector, so the function that we want to call. So we say so CallFuncN selector, and in here we have CCloud and reached destination, like so. That then is our move done action created, and now what we need to do is run these in what's called a sequence. And to do that, we simply say this object run action, and now we can specify a sequence of actions that we want to run. So we say cc sequence, and then we create our sequence, and we simply create our sequence from the actions we've made. So we have an action move, so the first thing that will happen is the cloud will move to its destination. When that's done, we'll then run the action move done, which calls the reach destination function, and this is an array being supplied inside here. We have to specify a final argument when it's finished of, not nil, sorry, that's Objective-C, null, like so. And that's all there is to it. This will now, when start is called, set our cloud moving at its speed in pixels per second to this destination, which is off screen to the left. So the last thing we need to do, or last couple of things we need to do then, one is inside the stop function for the cloud, we need to stop all the actions running on the cloud. And then down in reach destination, I'm going to do some scrolling here. We need to do the actions for when the cloud has reached its destination. It's gone off the left of the screen. So what we'll do is we'll set the position X of this cloud now to K cloud and it's restart X, so off the right hand side of the screen, and now we can say start moving again. And that's quite a lot of code gone in there. We haven't actually seen anything running in the app yet, but we need to set it all up. But it should be quite simple. We're just saying from wherever our cloud is, start, run off to the left hand side of the screen. When you get there, call reach destination, you'll get put back to the right hand side of the screen and you can start moving again. And if stop is ever called, then we just stop all our actions, which means it sits wherever it is, which means when we start up again we carry on from where we left off and carry on moving. Good. So now let's get all this into our scene, or onto our layer, and we need to add a couple of things into here now. We'll need to be able to create some clouds and then maintain a list of those clouds so that we can scroll through them all when the robin isn't flying to stop all the clouds, or when it's flying to start all the clouds off. To do that, we'll use something that Cocos2d supplies for us, which emulates an NS array, or a mutable array, in Objective-C, if you're familiar with that. And it's called the CC array, and it's really from the documentation from Cocos2dx the recommended way of maintaining any lists of objects. The only caveat is, I think, is you have to have the object that's contained in the CC array must subclass CC object, which if you look at layer where that comes from, then node, etc., they all do. That's the only caveat there, because it's basically mimicking how Objective-C works. Anyway, it's not really important for the tutorial. We have here a CC array of our cloud objects which we're going to use. And now we need to add some private functions in here, which will be fairly self-explanatory. We need to create our clouds, which we'll do inside there. And so we don't have too much code repetition, we'll have an add cloud function where we specify the speed and we set to specify the position that it's coming, so it'll be CC point, and then position. We'll specify the scale of the cloud, and now there's a much more efficient way of doing what I'm doing here, but for the sake of the tutorial and getting through things quickly, it doesn't really matter in this application. And then we'll have void and stop clouds to be able to stop our clouds, and we'll have void start clouds to be able to start our clouds. Okay, what's wrong with this thing here? Is that supposed to be a capital P? Yes, I think so. Okay, good. So I'll take these four functions then, just copy those and go into our Hello World scene. And below game update, I'll drop them in like so, create some brackets. And this video, I'm aware, is dragging on a little bit compared with previous videos. Sorry about that, but I'm sure you appreciate it's good to get all of this done and finished in one go. Start clouds and stop clouds there is now implemented and done. Okay, so the first function we want to look at then is the creation of our clouds. And the first thing we need to do is we need to, oops, I've forgotten the hello world prefix here, haven't I? You see how much, oh, I like the, in Xcode I particularly like the IntelliSense, and you can see how much I'm relying on it. So clouds, and to create a clouds we simply say new CC array, like so, and that then initializes our array. And it's really important not to miss this step, otherwise you'll get a horrible crash when you try to reference your array or add objects to it or anything like that. And now what I'm going to do is I'm going to add a cloud, and I've already prepared some cloud positions and things earlier so that we don't end up with a complete mess. So I'm going to do k cloud, and then we'll set up the slow clouds to start with, so the speed of a slow. Position of the first one is CCP 700 by 610, and I'm no artist, so if it doesn't look very good then sorry about that. And then we want the scale of the slow cloud, and we want the z index of the slow cloud as well. So that adds one cloud for us, a slow one. We'll add the next slow cloud, this time at 150 by 570. And now we're going to add in three medium fast clouds, as well. And change that to fast, change that to fast, and change that to fast. So the first one's going to be added at 150 by 300, and the red thing has appeared there, and I'm a bit perturbed as to why. It's disappeared, good. And then we've got 400 by 500. Okay, what's gone on here? K cloud scale. I don't have a scale for a fast cloud. Why haven't I got that? Sorry about this. What have I done here? Cloud. Oh, I've put score. Should be scale. Whoops. Okay. Good. So, I'm sorry about that. You've probably been wondering since the video started what in the world's gone on there. So, paste that in there. So we've got 400 by 500, and the last one is 880 by 400. So we've called the adding in now of our clouds, and the main bit we have to do now is obviously fill out the add clouds, so we actually put these onto our screen. So the first thing I'm going to do is copy the get visible size here into adding a cloud. Again, it's not the most efficient way of doing things, but it doesn't really matter. And now we want to create a cloud, so we'll say C cloud, which I need to include at the top here. So include cloud, so we can actually access our class. So C cloud and pointer to cloud equals C cloud, and then create cloud with file name, and then the cloud name we have is cloud-hd.png, like so. So that will create our cloud for us. And now what we need to do is just set some of the settings. So we'll take our cloud, and I spelt it could. I'm trying to get this done as quickly as possible because it's overrunning a bit and running into lots of errors. So cloud, and then what we want to do is we want to set the speed and width. So the speed we have is the speed we've sent in, and the width then is the visible size, because remember this is the width of the screen dot width. We then want to set the position, so we'll do cloud and set position, and I don't need all this inside here. Cloud set position, and I'll just simply set this to position. The next thing I need to do is set the scale of our cloud, so set scale, and we simply set this obviously to the scale that we've supplied here. And once we've done all that, we can now add this to our layer using the add child, and here we add the cloud and importantly the Z index as well. So this is now everything added. The last thing is to take our clouds array and add object and add our cloud. Next thing we want to do is, now that we've got our add cloud function working, everything, is we just want to drop this create clouds that's added after we've added the Robin here, so we actually create and add all of our clouds. And if we run that now, actually, assuming it builds, we should have hopefully some clouds sitting on the screen. I'm just building it here, and I'll just quickly run, and you can see now we've got some clouds on the screen. So to get them actually to move is very, very simple. We have to say that when the Robin is touched and set into a moving state, we will start our clouds. Otherwise, when the Robin goes off the screen here, you remember with the position here where the Robin's reset, then we'll stop our clouds. And that's all we need to do. And the last thing is inside the start and the stop clouds. Now I could have combined these functions into one actually and had an argument as a start or a stop, but it doesn't really matter. It's a bit of code repetition, but hopefully you don't mind too much. So what we have to do is iterate through our loop. So what you have is you have a CC object, iterator, because everything, remember, inside the array inherits eventually from the CC object. So that's our iterator, and there's a macro provided by Cocos2dx called CCArray for each, which you send in your iterator, your array and your iterator, and this now gets us a pointer to a CC object, which is our object inside the array. To get our object out, we have to actually cast, so we say a pointer to our cloud equals, and then we use something called static casting, because we know you can use dynamic casting, but we know what our object is. It's a CC cloud, so we don't need to do any clever dynamic stuff there. We can statically cast our object inside our array, and then on our cloud we simply call here, in this case, stop, and the cloud will stop exactly where it is. And I'll take this code and copy and paste it in here, and in this case we'll be calling start. Now, like I've said, the obvious thing that springs to mind is really to make a start-stop function with an argument saying if true then stop them, if false then start them, but hey ho, bit of repeated code. Repetition never hurt anybody except for the bugs later. So having done all that, we should be at the state now where I can actually run the app, and when the Robin's clicked, the clouds should start moving, and indeed you can see the clouds are now moving. Now the illusion isn't properly there of the Robin flying, and in fact something's going very badly wrong, and I've just seen what it is. If I go back into cloud.cpp, there's one thing I've forgotten to do here. The reset start position, of course, shouldn't be cloud restart x, it should be plus the screen width. They were restarting in the middle of the screen, sorry about that. I'll just run that again. And now we should see the clouds restarting from the right hand side of the screen, and indeed they are. So what I was going to say is at the moment it doesn't look too good because the the landscape below isn't moving, so it doesn't really give the illusion of flight, but we'll deal in the next video with how we then scroll the landscape as well. But what you can see, as soon as the robin drops off the bottom of the screen, the clouds stop and they restart when we touch the robin then. So everything seems to be more or less in order. Okay then, so that's it then for this video. Hope it was okay. I'm sorry there were one or two mistakes in there, but I don't want to have to repeat this video time and time again because it's a little bit longer. And like I said, in the next one we'll look into scrolling the landscape, and when we've completed that, we're actually very close to adding almost the final part of the app, certainly in the C++, which is simply the pipes that come from the bottom and the top that contain the gaps for the robin to actually get through. So thanks very much for watching. Comments, questions, criticisms welcome as always on YouTube.